Hi, this is Asutosh. Welcome once again in this course of indefinite integrals, and we are in lesson number 12, that is inverse substitution. So far we have done some problems or some techniques we have learned on substitution in which we have to substitute a function as t, but this time we are going to substitute the x as a new function. So let us understand how this can be happen. So first of all, we have some standard result which we have to apply. So the first result is whenever we see the integrand, if the integrand contains this x square plus a square and a is a constant, then we can substitute x equals to a tan theta or a equal to a cot theta. This theta is not necessary. We can substitute, we can replace this theta with t or u or whatever your favorite variable. Now, if the integrand contains x square minus a square, then we should substitute x equal to a sec theta or a cosec theta. Similarly, for a square minus x square, we can substitute x equals to a sine theta or a cosine theta. And if we have the integrand in the form a plus x divided by a minus x square root or a minus x divided by a plus x whole square root, and for this we can substitute x equals to a cosine 2 theta. So this is the main idea or the main result we have to apply in such kind of inverse substitution. Let us see some example to do. So suppose I have the integrand as 1 over square root, 1 over x square times the square root of x square minus 9. So you can see this is the key function x square minus 9, and this is the form, this is in the form x square minus a square, where a is 9, a is 3. So we can simply substitute x equals to a sec theta, because this is the form we can see here. So x equals to 3 sec theta we should substitute, and you can see that this time we are not substituting a function as a t, we are substituting x as a new function. So that is why it is known as inverse substitution. So dx will be now 3 sec theta 3 sec theta tan theta d theta, because we are differentiating x with respect to theta. And now the integrand will be 1 over, at the place of x we have to substitute 3 sec theta, so this will be 9 sec square theta, and in the square root we will have 9 sec square theta minus 9. So of course we can take this 9 out, and we will have this form 1 over 9. This should be, so this 3 and this 9 should get cancelled. So this is 1 over 3 sec theta, and this sec theta and 1 sec theta from here will get cancelled. So we will have 1 over 3 sec theta square root of 9 times sec square theta minus 1, and this is tan theta d theta. So of course after just taking the square root of 9 times sec square theta minus 1, we will get 3 tan theta. Why? Because the square root of 9 is 3, and sec square theta minus 1 can be written as tan square theta with the identity, and so this will become 3 tan theta. So and of course after this tan theta will get cancelled, and we will have 1 over 9. This should be 3 times 3 9. So 1 over 9, 1 over sec integration of 1 over sec theta. So we will have 1 over 9 cosine theta as the integrand. So we will have 1 over 9 sine theta plus c. So but we had to substitute, we have to give the answer in the form of x, not in the form of theta, because theta was our choice of variable, so we should not answer in this form. So for this we have to again transform this function which is in the form of theta into the function which is in the form of x. So we know that we have assumed that x equal to 3 sec theta. So from here we have to evaluate the value of sine theta in terms of x. So sec theta will be now x by 3. So we can see that sec theta is actually hypotenuse by base, so the hypotenuse can be x, and the base is 3. So if hypotenuse is x and the base is 3, this perpendicular can be square root of x square minus 9, and so we can write, assuming this angle is theta, sine theta will be square root of x square minus 9 by x, and so the answer is 1/9 square root of x square minus 9 by x, and that is our final answer in terms of x. So this is the way we have to do the inverse substitution. Let us do this example, and in this we can see this integrand is 1 over 1 plus x squared the whole power 3 by 2. So we can see this 1 plus x squared is in the form of a square plus x squared. Here a is 1 and x is x. So of course we have to substitute x equals to tan theta. So after doing so, we will get dx is sec square theta d theta. So at the place of dx in this integrand, we have to substitute sec square theta d theta, and of course at the place of x we have to substitute tan theta. So we will get 1 plus tan square theta to the power 3 by 2. So this will become sec square theta with the help of identity, and this 2 and this 2 will get cancelled. So they will have sec cube theta, but sec square theta was present in the numerator to cancel it, and it will become 1 over sec theta, and again it will become cosine theta, and whose integration will be sine theta plus c. Of course we have to write the answer in terms of x, so again we will do the similar process. Tan theta was x, our substitution, so sine theta will become x over the square root of 1 plus x squared, because tan theta is perpendicular by base, so we have to write sine theta as perpendicular by hypotenuse. So we have found the hypotenuse as the square root of 1 plus x squared, and so the answer will be x over the square root of 1 plus x squared plus c in the form of x. Let us do this example. In this example you can see that this is the square root of this expression, and this expression is 1 over root x divided by 1 plus root x. So you can see this is this is actually more like in the form of, more or less in the form of 1 minus x, a minus x, a plus x, the square root. So you can see this root x is at the place of x, and the 1 is at the place of a. So you can simply substitute x equals to cosine theta. That means we should substitute x, root x is equal to cosine 2 theta. So let us substitute root x is equal to cosine theta. So of course we will get x equal to cosine square 2 theta, and from there we have to find dx. So after differentiating it, we will get dx, and the derivative of cosine square theta will be 2 cosine 2 theta, and applying the chain rule we will get again for the derivative as negative sine 2 theta times 2. So after just simplifying it, we will get dx is equal to minus 4 cosine 2 theta sine 2 theta d theta. It means at the place of dx we have to substitute this all, and at the place of root x we have to substitute cosine 2 theta. So of course 1 minus cosine 2 theta is 2 sine square theta with the help of identity, and this 1 plus cosine 2 theta is 2 cosine square theta, and this will remain same. So here 2 and 2 will get cancelled, and sine square theta by tan cos square theta will be tan square theta, and when we take the square root of this tan square theta we will get tan theta. Again writing this tan theta in the form of sine and cosine, we will have sine theta by cosine theta, whereas cosine theta and cosine theta will get cancelled, and so we will have this sine theta cosine 2 theta 2 sine theta. So of course this 2 sine theta and sine theta will be multiplied together to get 2 sine square theta, and this cosine 2 theta as it is. But sine square theta and cosine 2 theta are the two trigonometric terms. So of course sine square theta has the power 2, so we have to reduce the power because we are applying here trigonometric transformation. So this is what 1 minus cos 2 theta by 2 with this 2 2 sine square theta is 1 minus cos 2 theta by 2. Let me just give you the cos 2 theta is 1 minus 2 sine square theta. So I should write here, let me just correct it. So this will become 2 sine square theta is 1 minus cosine theta. So this 2 will get cancelled, and this is actually negative 4. This is again negative 4. This is again negative 4, and this is again negative 4. Okay, so this will become 1 minus cosine 2 theta times cosine 2 theta, and after multiplying it we will get cosine 2 theta minus cosine square 2 theta. Again we are applying this thing, the same formula for cosine square theta. So this will become 1 plus cos 4 theta, because we know there's other formula for cosine 2 theta as 2 cosine square theta minus 1. So from here we can get that. Okay, so after the manipulation further, we will have this form, and you know that this is the answer in the form of theta. So you can also write that theta is half cos inverse root x, because we have taken this. You can see that here actually this x was cos square 2 theta. So when you find this 2 theta, that will be what, cos inverse root x, and so the theta will be half cos inverse root x, and so you can write theta as half cos inverse root x here, and keep this answer as it is. Or if you want to just expand it, so you have to use the identity of sine 2 theta, and again here also, and write that theta there, and write the answer in the form of x. Okay, so this is up to you. You can also write, or just keep it as it is. So now let us do this example. The integration of 1 over square root of a square minus x square we have to do. So again we can see this is the standard form, a square minus x square. So we should substitute x equals to a sine theta there. So dx will be a cosine theta d theta, and after substituting this thing, we will have a square minus a square sine square theta, and taking this a square out, we will have so from here actually this a and a will get cancelled, and we will have cos theta and cos theta will cancel too. So this is what, and this is d theta, and the integration of d theta is theta, and since we have assumed that x equals to a sine theta, so sine theta will be x by a, and theta is sine inverse x by a. So this is the answer, and this is actually the standard result we have to see in the next lesson. So that's all for today's lesson. This is actually here we have discussed some inverse substitution process. In next lesson we are going to apply this inverse substitution process to derive some important results, and also we will see how this result can be applied to deal with some problems. So thanks for watching.